So a correlational study, like we've been saying, shows a relationship exists between two variables. Correlation coefficient is how we numerically represent correlation. The correlation coefficient, which is lowercase r, I'm going to have to add that. I believe that it is it's in your notebook. Lowercase r equals anywhere from -1 to 1. R of -1 or close to -1 means there is a strong negative correlation. That means, for example, the more time someone studies, the less anxiety they may experience. We have an inverse relationship. If I were you, I would make a note of an arrow going up and an arrow going down, because we see the variables moving in the opposite direction. The more time studied, the less anxiety experienced. Strong positive correlation would be R at or close to 1. Now, SAT scores are supposed to strongly predict college grades, though we're going to learn the relationship is not nearly as strong as it purports to be. There is a positive correlation between SAT scores and grades in college, meaning the higher SAT scores, the higher your grades in college. However, that correlation is not a strong positive correlation. R equals 0 or close to 0 means that no correlation exists. In other words, your shoe size does not predict your GPA. There's no relationship between shoe size and GPA. So we numerically represent correlation using R, -1 to 1. But then we also would graph correlation using a scatter plot. So negative correlation looks something like this. All right, our line is sloping down. The more mileage on a car, the less that car is going to be worth. The second you drive it off the lot, its value starts to depreciate. Positive correlation, our line is sloping up. The more accidents you're in, the more your car insurance is going to cost. Those two variables are positively correlated. One's high, so's the other. One's low, so's the other. Those arrows that I told you to draw, they're both moving in the same direction, either up or down, as opposed to negative where one's going up and one's going down. No correlation, we'd expect our scatter plot to look something like this, with our points all over the place. Like the quality of your car has absolutely no correlation with the color of the car. So we have to be really careful to not create what we call illusory correlations or to perceive a relationship where none actually exists. They can feed or contribute to us feeling an illusion of control over things that we don't really have, and they're fueled by something we call regression to the mean. Regression to the mean is a kind of a statistical principle that says that after an unusual event, things tend to return back to normal or back to average. So, for example, if I have one year where AP scores are just off the charts, the following year, I shouldn't expect my scores to be off the charts again. It's likely that they're going to return to more of a normal or more of an average. And this can lead to illusory correlations because it can lead us to kind of draw false conclusions about how much control we have. And I'm going to use the example of speed cameras. So when speed cameras are installed in an area, they're usually installed in an area because there's a high number of accidents in that area. This means there could be bad road design, but it could also just be a product of luck or chance. So we've got this really bad intersection, poor design, also probably a good deal of just statistical chance leading to bad luck. After the cameras are installed, accidents are going to go down. We might say, well, the accidents go down. It's because of the red light camera, without acknowledging regression to the mean, which is that, okay, by chance, there happen to be a lot of accidents in this area. Eventually, those accidents are going to peter off a little bit. There's not going to be as many. It's going to go kind of back to average. Whereas you might have an area with no red light camera that by chance starts seeing an uptick in the number of accidents that they have. So we've got to be careful not to assume that it's the cameras that decrease accidents. And we'll talk about some other examples in class. I actually linked to a really good video that uses this speed camera example as just one of a few examples that they use. So I encourage you to check that out too. But bottom line is we are programmed, our brains are programmed to see causal relationships where they don't actually exist. And regression to the mean, if we don't acknowledge regression to the mean, this is something that could fuel us to see relationships where none actually exist.